All right, we're going to review the answers for the lab problems for Chapter 4. We had problems number 4, 5, 15 with some special instructions, 17A and B, 26A and B. Question 4 says, is it possible to obtain a negative value for variance or standard deviation? Absolutely 100% no. There's two ways of thinking about this. First of all, remember that if we're computing variance or standard deviation, we have to also compute the sum of squares, the sum of squared deviation scores. Why do we have to do that? Because we had to get rid of negative values. That was the whole point of squaring things in the first place. So we've already eliminated all the negatives. The other way of thinking about this that's kind of useful in more of a long-term thought in this course is that, remember, one of the ways we said that of describing variability is that it's describing distances between scores. And there's no such thing as a negative distance. All distances are positives. You can't show me a table that is negative 10 inches tall, right? It doesn't exist, not in our universe as we understand it. So distances are always positive. Therefore, measures of distances will always be positive. Range is always positive. Again, variance and standard deviation, always positive. Sums of squares, always positive. So that's an important thing to know beyond just sort of math trivia, I suppose, that if you are ever working on computing one of these problems and you get a negative sums of squares or as a result a negative standard deviation or variance, you've made a mistake. You cannot get a negative value. Question 5, describe the scores in a sample that has a standard deviation of 0. Standard deviation measures the average distance of raw scores from the mean. Well, if the distance on average is 0 points away, that means it's not distant at all, right? How could you get a range of 0? Well, the only way you can get a range of 0 is if the highest score and the lowest score are the same, right? If the highest score is 17, the only way to make the range 0 is to have the lowest score be 17. 17 minus 17 is 0, or 20 minus 20 is 0. So how does that happen? If all the scores are identical. It's 0 variability. So you would get a 0 range, you'd get a 0 variance, you'd get a 0 standard deviation, you'd get a 0 sum of squares. Everything comes out to 0 if all the answers are literally the exact same answer. So that's number 5. Number 15, I've got us a little bit of a head start on here. So it gave us all these raw scores, and it said that it wanted us to compute sum of squares, variance, and standard deviation for this sample of scores. So our sum of squares is the summation of the raw scores squared minus the squaring of the summation of raw scores over the number of scores. So we've got everything basically we need here. We know that this says to square the raw scores and then sum it up. Here's my squared raw scores, and when I sum it up, I get 32 points. This says sum up the raw scores and then square it. Well, the summation of raw scores is 12, so 12 squared. And then over how many scores are there? There are 14, I believe. 1, 2, 3, 4, 5, 6, 7, 8. No, what did I just look at? Oh, yeah, no, 8, sorry. And the number of scores is 8. The answer is 14. So that is your sum of squares for this sample of data. Then it says go ahead and give us the sample variance. So we know that sum of squares over degrees of freedom, or sum of squares over little n minus 1. So that's our 14 over 7. 8 minus 1 is 7. So here we have a 2. Our variance is 2. The average squared distance between raw scores and the mean is 2 points. And then lastly, turn that into standard deviation by getting the square root of variance. So the square root of 2 is 1.41. Then I asked you to go ahead and redo all this as though it was from a population, just to practice the other side of that. So, first thing is sums of squares. Well, the only thing we would technically change there in the formula, remember, is converting that to a capital M. But mathematically, this is the same. So for the redo, if you will, of 15 as a population, sums of squares is still 14 points. Remember, where the difference really comes in is right here. We're not going to divide by degrees of freedom. We're going to divide by the, oops, I got to change the symbols over here too. We got to divide by the total number of scores for the population. And so the total number of scores here is 8. So it's 14 divided by 8 now instead of 7. So now we get a decimal on the side of 1.75. And then lastly, for population standard deviation, we simply get the square root of population variance. So we get the square root of 1.75, which equals 1.32. So there we go. It's just a matter of being organized. Get your little scratch work all set up, and when that's all set up, it's just plug and play. Put it in the formula and see what you get. So those are the answers to 15, both versions of it. Next up was question 17, and it said we have a population with a mean of 50 points and it has a standard deviation of 10. So we have a mean of 50 and we have a standard deviation of 10. And A says if 3 points are added to every score in the population, what would the new values for the mean and the standard deviation be? So this is drawing on those characteristics of the mean and characteristics of variability. So this is drawing on both chapters 3 and 4. So if you add 3 points to every score in a distribution, what happens to the mean? It goes up by 3. So the new mean would be 53 points. The standard deviation would be unchanged. Remember, you add 3 points to every score of the standard 3 points to every score of the distribution. We're not spreading them out more or condensing them in. We're just sliding them all up and down as a set. So there's no change here. This remains 10. Now in part B, it says, what if we multiplied everything by 2 instead? Well, if you multiply every score by 2, what happens to the mean? It also gets multiplied by 2. So the new mean would be 100. And remember, variability will be affected by multiplying and dividing. So the same thing applies down here. The new mean would be 100 and the new standard deviation would be 20. So that's problem 17. And then lastly, we've got problem number 26, parts A and B. 26 says, on an exam with a mean of 39, you obtain a score of 35. A says, would you prefer a standard deviation of 2? Or would you prefer that this has a standard deviation of 8? Now note the hint in here. Really pay attention to the hints. If the book gives you a hint or I give you a hint, it really is an important hint to take. And so it says, sketch each distribution and find the location of your score. This goes back to that sort of second objective of measuring variability, kind of descriptive statistic stuff. So the question here is, which one of these would you want? So let's say, let's make it personal. You're in a class where you took an exam and you got a score of 35 points and the class average was 39. Which of these standard deviations, which of these values would give you the best grade, or we would say the highest position in the distribution? Well, we simply need to make 2 different sketches here and compare them. So let's start with this one. We know the mean, it says, is 39. Let's put some standard deviation lines in here. We'll put a couple in here. And in this first version, we're going to count by 2s. So remember, standard deviation, when we move a line, that's how many points we moved. In the lectures, we just moved 1 line, but the lines go out for infinity. So 39 plus 2, so 39, 40, 41, 42, 43, going down by 2s to 37 and to 35. And so remember, what we know is that everything between here and here of these 2 goalposts is roughly 70% of all the scores. That's the common area, right? That's where the typical bear is living. So most people, 70% of the people, scored somewhere between 37 and 41. How did you score? A 35. Well, that's probably not very good. So let's see what happens if we go with the other version of this. So the mean is 39 still. But in this version, we're going to count by eighths. So 39 going up by 8, so 39, would that be 47 and 55, and down by 8 would be 31, 21, 22, 23. So now your raw score is still a 35. Again, everything in this middle between these first two lines is where most of the scores are, and now your 35 is right here. So if this is you, your exam performance, would you rather live in the universe with a standard deviation of 2 points, which would put you below the common range, below average performance, or in a world with a standard deviation of 8 points? Well, now, again, you're below the mean, but you are in the range of scores considered common or average or typical. So here you're probably flunking. Here you're probably getting a C. Well, choice between a C and an F, I guess if those are our choices, we might as well take the C. So for 26A, we would probably want to choose a standard deviation of 8 points. Now B is the same idea, that we've got a mean of 39, but now we're going to change your raw score to be 43 points. And we're still asking the standard deviation of 8. Oh, I wrote 6 there, 8. And we're asking the same thing. Now that your score is a 43, would you rather be in a class with a standard deviation of 2 points or 8 points? Well, the graphs are the same because the mean is the same. So 39 up here counting by 2s. If your score is a 43, you are up there. And on the bottom one, if your score is a 43, you're here. In both cases, you're above the mean. But again, in this top one, you are well above the mean. You are outside of this common range. So that's probably an A performance. Over here, you're right in this zone of where the common scores are. So if we got to choose for part B, we would probably want to be in the universe with a standard deviation of 2 points, because that'll put us well above the common range, well above the average performance. You're going to be doing a lot of sketching and drawing as this course moves forward. It's often a great way of solving a problem, and we can see that there are other ways mathematically, we'll see in the next chapter, that we could have solved this problem. But here, without formulas and without calculators, we can still work our way through it by applying our descriptive statistic logic here. All right, gang, that is Lab for Chapter 4. You know the drill. If you've got questions, reach out, let me know. Otherwise, carry on, study hard. We'll see you for Chapter 5.